Bismillahirrahmanirrahim. Assalamu warahmatullahi wabarakatuh. Today we'll be talking about a chapter called KNX Secure in our KNX Advanced course. The chapter for the secure part is a theory part and a non-site practical part. So part of what we are seeing today will be implemented in our practical sessions as well in our lab or on-site, inshallah Rabbil Alameen. This chapter is a little bit of a new chapter. It was rewritten very recently, okay? Almost totally, completely rewritten to allow more up-to-date contents in the chapter. The chapter will have two questions coming about it in the theory exam, and in our question bank will have 19 questions, inshallah. Okay, let's have a quick background about KNX Secure. The KNX Secure is different than KNX Security. KNX Security is a different chapter. It's talking about securing a KNX site, KNX installation, okay, like intrusion detection, like fire alarm, stuff like that. However, KNX Secure is talking about the data security passing on the bus of the KNX. This bus might be TB bus, it might be IB interface, it might be RF. However, how to make sure that this data is secured against cyber attacks, against replaying attacks, any kind of this kind of hacking attacks. Okay. If you recall from the basic course, in the diagnostics part, we used to put our USB interface and then we can make a bus scan and get a lot of information about the installation I have in hand. Okay, so we can have a line scan, then I find the individual addresses. I can then start finding the programming object of them. I can even reprogram them again using parameters and ETS. Okay, which is not a very secure way. This is why KNX started putting the KNX Secure methodology and the framework in implementation, and even you will find a course or a chapter in the ETS campus, in the KNX campus on KNX Association website. You'll find a free online course talking about KNX Secure with a checklist of what you should do to secure your project. Okay, so let's talk about what KNX is doing to secure the KNX installation against cyber security. Okay, in this part, okay, it's bigger than this part. This part is focused about data transfer, but it's bigger than that. Okay, and we'll try to cover some of the other let's say points not mentioned here. We'll try to cover on site, inshallah, or on our YouTube channel we'll put some other videos talking about the methodology in general, because it's a very important methodology regardless what will come in the exam or not, or what will not come in the exam. It's very important for you to make sure that your installation is very secure. Okay, the concept KNX Association is trying here to introduce is about authentication. It's the concept to make sure that the data sent from one device to the other device is authenticated, meaning sure that it is coming from this device. Okay, so this device is sending this data, and this data is authenticated. It's not manipulated somehow. Okay, this is why they introduced here the concept of authentication, and they are trying to make it look like you have a passport. So this device telling me that I am the authenticated device using something called a passport, which is some kind of a key. And if I can make sure that this key from this person I can check here, then I know that this data is authenticated. So I have authentication code here, which is the passport, and I have a sequence number to make sure that this data is not replayed. Okay, so it's not a copy of the data that I've seen before. This is the concept of authentication. Then they added another part, which is the encryption, making sure that this data, even if someone in the middle seeing the data, it cannot be interpreted. He cannot read the data. Okay, imagine you are on the phone and talking to someone of your friends, and then someone in the middle is tapping the phone and is able to listen to your talks. Okay, if you are talking plain text with your friend, then it's understood, no problem. But if you are talking in some kind of a weird language, let's say, then the other guy tapping on the phone trying to listen, he needs now to de-encrypt, to retranslate this data to be able to understand that. This is the concept of encryption. Okay, this is why we are talking about secure. We'll talk today about IP secure, okay, couplers in general secure, and device secure. So we can have security on the borderlines. So IP routers are secured, meaning that they're sending encrypted data. Couplers are secured, meaning that they're sending also encrypted data. or devices like actuators or keypads are also sending encrypted data. So even on the same line itself, devices are sending encrypted data. So if I'm tabbing or having a group monitor or a bus monitor on the line itself, I cannot see anything. I cannot understand what's going on, which is very important. Okay. So this is the concept one for the data secure. This is for the device itself. So devices itself, when you see the green one, meaning the secure one. Okay. So here the devices are sending secured, couplers are sending secure data to each other and to the IP device. And if you're using data secure meaning the device itself is secure. So the devices themselves are sending data to the line coupler, which is also secure, sent to the IP coupler. So the whole, let's say, area is secure, internally and outside. Okay. If you're doing any secure devices in your project, then you will have to enter a project password for ETS. Remember, in the ETS, we know that there is a project, a password for the project. Okay. To make it also simple, when you are buying an IP router or a coupler or any other device, even an actuator now, you can find that there's a normal version and the version that we call it secure. Secure version comes with a key. Okay. The key is used for the authentication and for the encryption. Okay. So this is very simple to summarize what's coming in the next few chapters. So I want to secure my data on the border. So I am buying an IP router which is a secure one. I did not buy the other one that's not secure. Then there is a key coming from it. And once I insert a device which is secure in my ETS file, I have to enter a password to create a new password for the ETS file. Okay. And the password should be strong, of course, because ETS is putting a strong methodology for the password itself. Okay. Why should I put this password? Because the security keys are saved in the ETS file. So I want to make sure that if this file falls in the wrong hands, no one will be able to open the file. Hence, he will not be able to access the keys I have stored in the file. Okay. But also I have, remember when we get to the details before in ETS, you can go to details, security, and you can see how many secure device you have in your setup as well. Okay. This will be doing in the practical part, by the way. So this is only the theory part, but we'll be doing this in the practical part as well. This is when you go to security and you find that you can have here the secure device you have in your list with their keys. If you want to add another device, you can add from here. You can even have a backup from the keys itself from here. And this backup, of course, you have to keep it in a very safe place. When you have a new device, a secure device, it usually comes with a QR code on the device itself and a plain text. This is the key, by the way. The QR code is the key, or the text is the key. If I have, let's say, a webcam on my laptop, I will be notified to open the webcam, so the laptop and the ETS via the webcam can read the QR code and hence enter the key automatic. If I don't have this, then I have to enter the key manual. The key is available here on the device itself. So each secure device will come with a label on the device with the QR code and with the key, both holding the key. And once you installed it and the key is saved in the ETS, it's better to remove this ticket, remove this label, and keep it in a secure place. So even if someone managed to get hold of the device, the physical device, he will not be able to understand or to know the key. Okay. This key, by the way, what we call it here, FDSK, okay, is normally not used in the operation. So this slide is trying to tell you that this key is only used in the beginning, okay, to generate some temporary keys and some tool keys, okay, runtime keys. Then it will be saved in the ETS, but not send on the Telegram to make sure that it's secured. But what is sent on the Telegram is the tool key or runtime key. These are the one that is being used in the communication itself. However, they were developed or used or generated using the key. So this key is the origin of everything. This is why I have to make sure it is secured. Okay. If you have any device and you want to check the topology, you'll find that your IP router or secure device will always have this shield. You see this shield, this blue shield, meaning that this device is secure. If the device doesn't have this, then it is not secure. Then I have devices which are secure. Let's say an actuator, a secure actuator, and another, let's say, keypad or actuator not secure. This one is secure, okay, with the shield. This one is not secured, okay, not secured. To make sure the devices or the communication is secured, then I have in the group address to insert group objects from a secure device to group objects from a secure device as well. Make sure that this device is sending data to this device in an encrypted way, because at the end, you know that when you press the button in the keypad, you are sending the signal from the button to the actuator, which if both are in the same group address, telling the actuator you have to go on or off or do something. Okay, so this data should be encrypted, and the only way to encrypt that, if they are on the same bus, on the same line, that to have a secure actuator and a secure keypad and put the group objects of both together in a secure group address. So I have to tell the group address you are secured. So here is trying to tell you that if you take a look on the group object of this device as an example, this is a secure device. But some of the group objects are placed in a secure group address and some are placed in a non-secure group address. So this one is placed in a secure group address because I have the shield. This one is not placed in a secure group address. So it's placed in a plain group address. Okay, this means that in our group address I have settings to make sure that it is placed in a secure group address or not. Okay, here it want to show you that even the group address itself, you can see that this one is a secure group address, meaning that its setting is on for the security or auto, and the devices or the group objects in the group address are a secured one, but this one is not secured. Okay, let's take a look on the settings for the group address. So now with the secure, you will find that in the group address itself you have three settings. It's automatic or on or off. If I choose automatic, then ETS will check. If I have all the group objects secured, then this group address is a secured one. Data will be sent from this device to the other device within the group address in a secure way. Okay? However, if I try to put another group object which is not secure, then it will be allowed with a warning. So ETS will allow me to insert in this group address one group object not secured, but will give me a warning. Okay, and then the whole group address will not be secured because I have a group object not secured. However, if I have the on option, then I cannot put any group objects which is not secured. So all, if it's on, then all group object should be secured. If I try to put a group object unsecured, ETS will give me a failure. Not a warning here, no, but a failure message. It's not allowed. However, if I make it off, then the security is not enabled anyway. So if I put a secured group object, non-secure group object, that is not secured anyway. Okay, so this is what I have here. If the settings is on and I try to put a non-secure group object not secure, then it's not possible. Okay, however, if the settings is auto, then I have something like that. I can confirm or I can cancel. So it's optional. Okay, same thing for the IP backbones. For the IP routers, I can have the IP backbone like here using an IP router which is secure. Then I can choose the IP backbone itself to be secured, automatic on or off. Okay, so data is secured, will only be sent to IP router secure, or it's fine. If it's on, then it's fine. Then I have to be sent to an encrypted one and a secured one. Automatic, then it's fine. I will try to use it. Off, then I will not use it. Okay, same methodology. Okay, same thing you can see here. It's an auto one, so I'm telling it that one of them is not active in the security, then it's the whole IP backbone will not be secured. Okay, like off. Here's the same thing for IP secure router. We have the same methodology for security. You can activate security on an IP router or deactivate security, and this we'll see in the practical part on site, inshallah. If I have an IP secure router and I'm trying to use it as a tunnel gateway to access it using the ETS or using remote applications, okay, then ETS will not allow me to access this router until I pass those passwords. I have to put the commissioning password and the authentication code to make sure that not anyone with access to the IP router physically has his laptop connected to the IP router is able to access the system. Okay, no, if I'm trying to access the system remotely or locally, then I have to enter this password, ETS will ask for that. Okay, this password. Okay. If not, then I receive the error message like that. If I don't have the password, the right password, I'm trying to use the IP interface. Okay. Then I did not put the password, then I got a login field, I cannot access the system. Okay. Now another part here we're talking about is the, if I have now my ETS file, not the right ETS file, a normal ETS file without the security data in it. So it's a hacker inserting his USB device trying to read the data. He run the bus monitor and trying to read the data on the bus. Now we know that the data on the bus is secured if they are using in a group address which is secure. So data transfer is secured. You will find that the hacker will not be able to see the useful data. Remember in our course we said that the Telegram has a lot of functions, a lot of parts. An important part is the useful data. This is the part in the Telegram that's saying the text message or the reading of the motion sensor or sending the data to the actuator to activate the actuator on or off. Okay, so this part is the useful data, and if I have my ETS file not the right ETS file, then I cannot read the individual data. As you can see, it is, for me it's hexa code that I cannot read. However, if I'm using the right ETS file, because my right ETS file will have the keys and the certificate already saved in the ETS file, then ETS will be able to encrypt the data and I can see the right data in front of me. Okay, so if I have the right ETS file, then I will be able to see the data inside the Telegram itself when I run bus monitor or group monitor. Okay, can I print or get the data about my project with certificate? Yes, you can go to the reporting function, reporting panel, and you can get project certificate and project security, and you can get the keys, okay, printed out in front of you, the list of devices print in front of you, and then you have to make sure that those printout is secured. Okay, one part also you need to enter if you want to secure your KNX illustration, then also you should use the BCU key. Okay, if you call BCU key is the key that if I'm using, then the download on the bus is not possible. So my devices are now almost read only. I cannot download the bus until I use the BCU key. So the whole framework is ETS password, BCU password or BCU key. Also you need to put devices as much as you have with a secure key. So you can have the couplers, routers, devices using secure key. Okay, keep the secure key safe. Okay, remove remove the label from the device itself. Okay, then last but not least, the physical security. So you have to make sure that if your installation is put somehow in a public area, so no one will be able to access the bus. Okay, make it even harder for them. So you can put a good lock on the access public areas, or you can put a camera, or you can put an intrusion device. Okay, you have to do this as well. By the way, don't confuse secure, KNX secure against KNX security. KNX security is managing the intrusion detection in KNX using KNX to secure a location, but KNX secure is using the secure technology to make sure that KNX setup and data traffic is secured. Okay, you'll also find in this link a PDF file that KNX Association has with a list of things or tasks item that you have to take care of when you are doing your project. Part of it is related to security, so a checklist that you have to check when you are finalizing a project to make sure that your project is secure. Okay, so in the summary, you should use in your illustration Data Secure and IP Secure. Okay, then you can use more than one level of security in parallel. It's even recommended. Okay, if you have a secure group address, then data will be secured. If you don't have a secure group address, then data will not be secured. Okay, secure group address meaning that all devices and the group objects in a secure group address should be from a secure device. Okay, you can use more than one security device, and this can be integrated with secure device and even with non-secure device. Not secure device will not read the secure data and then will be cancelled, and even the secure device you have, you can implement them in a secure way or in unsecure way. If you choose to cancel the security, then they are working like a normal device. If you did not apply an ETS password on the file of the ETS, also security will be disabled. Okay, so if you are applying in part of security, then ETS file on the ETS password on the ETS file is a mandatory, and this is done to protect the keys inside the ETS file itself, and all of this should be kept in a secure place. Okay, that was the KNX Secure. We'll talk about it more in more details in our on-site part, inshallah. If you have any question, let us know, and see you inshallah in the next session. Assalamu alaikum.